All right, last time we focused on or probabilities. The probability of A or B happening. Two different events happening. Now, we're going to start to talk about the probabilities when we talk about two different events happening together. Two different events happening at the same time. And so the first way we can talk about two things happening together is what's called a conditional probability. And it's called a conditional probability because we're talking about another thing happening under the condition that some first thing happened. And the first thing that you need to know is that the notation is that we have the probability of B given that A happened. So if I already know that this first thing happened, what is the probability of the second thing also happening? Now, the easiest types of problems with these are actually with tables. And so let's take two different events. We have the grade coming from an engineering and physical sciences course, and then the event L, the grade is lower than a B. So in other words, we're focused on this row, engineering and physical sciences row, and then this column below a B. So first off, we want the probability of L. Probability of L. So the probability of below a B. Well, if we want the probability that they're below a B, we're going to take all the times that they were below a B out of everybody. So first we need to get our totals. And we see that below a B is 3,656. 3,656 of the students out of the 10,000 there were total. So that's the probability of L. Then we want the probability of E given L and the probability of L given E. So these two are actually going to be slightly different answers. So see if you can pick apart which one is which and what the difference between them is. So the probability of E given L is saying given, so you should think of this as the second thing, the given first. So given that they were below a B, what's the probability that they were in engineering and physical sciences? So another way you can think about this is that we're playing a guessing game. So I'm saying I'm thinking of a person in this school, and the first thing I'm going to tell you about them is that they are below a B. They are in my below a B group. What are the chances that they are out of the engineering and physical sciences group? Well, we're going to take, since I've already told you that this person scored below a B, we're going to take all the group of people that scored below a B, and out of those, we're going to decide how many come out of the engineering and physical sciences. So out of all the people that scored below a B, how many of them were in engineering and physical sciences? That's how we get that probability. Now, L given E is a little bit different. L given E says I'm thinking of a person, and this time I'm going to tell you ahead of time that they're out of engineering and physical sciences. So I have told you they're out of engineering and physical sciences. What are the chances that they scored below a B? So I'm thinking of a person, they're in engineering and physical sciences. Well, that means that I have 1,600 possible people. Out of those 1,600, how many of them scored a B? 800, so that's exactly 1/2. So that's the difference. The second letter here, or the second event, is the thing that you are told, the thing that you are given. So that's what you want to go in the denominator, because that's what you're already told. That's the group that you're taking the probability out of. So jumping around a little bit here, we can get a general multiplication rule from this. which is that if I want to find the probability that two things happened at the same time, right? If I state this out into words instead of notation, it's going to make a lot more sense. So the probability that two things happen together, well, the first thing I need is for A to happen. If I want both A and B to happen, then I need to talk about A happening first. Well, then after that, given that A already happened, B also needs to happen on top of that. So I need A to happen, and I need B to happen at the same time that A has already happened. Because remember, this is B given that A has happened. And so we're going to take those and multiply them together. Remember I said that OR probabilities, we're going to add. With AND probabilities, we're going to multiply. So since we're trying to have these two things both happen at the same time, we're going to multiply them together. I want the probability that A happens, I want A to happen, and I want B to happen at the same time that A happens. So that's how we can multiply these two things together. Now we'll have an easier formula for this when two things are what we call independent. And what I mean by independent is that one of the events doesn't have an effect on the other. So in other words, if I know that A happens, that doesn't have an effect on B happening. My usual example is flipping a coin and rolling a die. Right? If I flip the coin and I tell you that the coin landed heads, that doesn't change what your prediction is for what the roll is going to be. It has no effect on each other. If the effects are dependent, that means that me telling you something about the person does change the outcome. So in the last example, notice that the probability that they scored below a B changed when I told you they're from the engineering and physical sciences class. That probability went up. So independent and dependent doesn't mean caused. It just means it alters your chances that something happens. It changes your guessing game when I tell you that information. If it doesn't change your guessing game, then it's independent. So when I flip the coin, that doesn't change your guess on the roll of the die. So the way to state that with our conditional probabilities is that the probability of A given B is A, and the probability of B given A is B. So in other words, if I tell you, let's take B given A being B. In other words, if I tell you that A happens, that doesn't change the chance of B happening. It still stays the same as if I didn't tell you anything about A. Same thing the other way around. If I tell you that B has happened, that doesn't change your probability of A. So combining these two rules together, if two events are independent, usually we need to keep track of when does A happen and when does B happen if we know that A happens. Well, if two things are independent, then knowing that A happens has no bearing on whether B happens. So instead of saying we need to know whether A happens first, we can just say, well, let's take probability of A times probability of B. So if two events are independent, then the probability of A and B is just the probability of A times the probability of B. So to wrap this all up, we can reframe this rule to find the probability of a conditional event. So in other words, if I want to solve for the probability of B given A, and I want to find that instead, then I can just divide by the probability of A on both sides in this formula, and that can give me the rule for conditional probability, which is that the probability of B given A is the probability of A and B over the probability of A. And we did this in the table. we said if I tell you that A happens, then that's what we're taking our probability out of. Out of all the times that A happens, how much does B also happen? Out of all the times that A happens, how often do we also have B happening? That's our conditional probability. That will tell you the probability of B given that A has happened. So whatever you're given should go on the bottom of your fraction. That's what you got to remember for conditional. So those are all the formulas and definitions that we're working through so that we can focus next week on going through some examples together and talking in depth about some problems. So that's what we'll be doing on Tuesday, so I'll talk to you then.